Okay, so the last video kind of ended abruptly, ran into that 15-minute window. So electron configurations, we're just kind of going over stuff. I mean, the stuff you had last year. And so highlights were the idea that each of the blocks, which you really need to know the blocks, has a certain amount of electrons in it. And then you can basically count that by looking at the number of electrons in a particular row. So you could count 6 there, 2 there, and 10 there. Well, that's the maximum amount of electrons that those particular blocks can hold. So that gives you kind of an idea on some of that. So, okay, the energy level is the row. And so the energy level, that's the row, but that's also going to be the distance from the nucleus. So you have a couple of things going on there, but I think for most students, remembering it as a row is probably the best situation to just have success, because I don't think that I think that most of the time electron configurations are usually tested via just can you do one. So let's go ahead and write that in. So principal energy level, that is going to be a row. And so then obviously there's only 7 rows, so it has to be a value of 1 to 7. And then maybe we write in below that this is going to be the distance from the nucleus. So distance from the nucleus. So that might also be useful. So don't want to run into my periodic table because I'm going to need that in a minute. So try and tidy this up. Okay. So electron configurations, this is what you did last year when you were doing 1s2, 2s2, all that kind of good thing. And so basically it says electron configuration describes the distribution of electrons among the orbitals, the number of electrons with a subscript in each sublevel. So what does that mean? Well, it basically means we're putting every single electron in a place. And what you really need to ask yourself when you're doing these things is you need to ask yourself 3 questions as you move across the periodic table. You need to say, okay, what row am I in? So that's 1, 2, 3, 4, 5, 6, or 7. What block am I in? And then how many spaces am I going to use, or how many electrons? So, how many spaces? Because each space is an electron. Okay, so if you ask yourself those 3 questions, you're usually going to be pretty good at solving this pattern, which this really is just a pattern. So the row, you get 1 through 7. The block, you get S, P, D, or F. And then, of course, the spaces can vary depending on what you need. So, all right. With the periodic table, we do want to highlight one area that is rather important, and that is right here. This is 4S, and then this is 3D. So there is an overlap in 2 places. The first overlap is right here, and that's 3D, and the second overlap is down here on the F block, where you actually have 4F and 5F. So we have to identify those, because if we don't spot these places, then we'll be like in row 4, and then we'll say 4D, and that's incorrect. So there's an overlap, and it's because it's a 3-dimensional object. And so I'm going to show you that here, this idea of these shapes over here on this video. So I'm on this model of the atom here on YouTube. And so if you look, that's kind of breaking down everything into shapes. So S is in blue, P is in yellow, D is in red, and then F is in green. So you can see that the S shape, spherical, just very basic. Then you can look at the, increase our quality here a bit. Then we can look at the other shapes, and we can tell that there is, so there we go, got the quality a little bit better. So now if you look at this, what's going on here is this is just the 1s. And so if you pause it, you'll see there's 2 electrons just buzzing around. So this is a space that can hold 2 electrons. That's called an orbital. So there's 2 electrons zipping around in there. And so what happens is if you cut it in half, you can see those 2 electrons, and they're just inside, and they're kind of moving around. So let's kind of slide this forward a bit. Okay, so then there's this layering effect. So if you look at this now, that's a 1s and it's also a 2s. So you can see that the second layer is just on top. And this is the idea of layering. This is a 3-dimensional object. So now you got 4 electrons. You got 2 in the middle area and 2 in the outside area. And they're just buzzing around, moving in a bunch of places. And you can kind of see from this picture here, this cross section, that the 1s is inside and 2s is outside. They're layered. And then there's 4 electrons, 2 on the inside and 2 on the outside sphere, and they're just spinning around. Remember, they're negative, and so when they get next to each other, they repel. Okay, what do we got here? We're now integrating the P. So this is 2P. So the 2P is the dumbbell, and so you have an X, a Y, and a Z axis. And so when you look at this thing, there's going to be actually multiple of these yellow areas, and those are the p orbitals. And so it's just stacking, everything stacks. So 1s2, 2s2, 2p2, etc. It just stacks and stacks and stacks. And so now these p's, they have 6 electrons, so there'd be 2 electrons spinning around in each of those yellow sections. And so you see that there's this layering effect. So every layer, you get a little bit farther out. Okay, now if you look here, you can see that there has been extra layers put on. So now you have another S, you've got your 3s, and you can just see that there's a stacking of layers. If you look at that, you've got the 1s, got the 2s, got the 2p, you got the 3s and the 3p. So they're just layering. So those yellows, there's more yellows because there's now, this is sulfur, so you have more layers. So as you add and add and add layers, it just gets farther from the nucleus, and it starts to get more and more complicated. You can see those electrons buzzing around in there, and they're just moving in the orbitals. So when we draw a box with arrows, what are you drawing? You're drawing these spaces. So we're trying to represent a very complicated item with a very non-complicated way. And so it's just more stacking. If you look at that, you can see that there have been some d orbitals added in red, which makes it even more complicated because they have 5 places. So there's 5 places that electrons can go for the d. And you can just see more and more and more stacking. And so it will just continue to layer and layer and layer. So anyway, hopefully that gives you a little bit of an idea on. All right, so we're gonna switch back here. Might have got a little clunky in the transition. It's kind of hard switching back and forth on Windows on this thing, but okay, hopefully it gives you an idea of kind of of what's going on with the shapes. And so so what do you got to be able to do? Well, at the end of the day, you've got to be able to do an electron configuration. Okay, so let's go over here and let's write out some electron configurations. And so you've done this before. This is not new, but you have not done this in a while. So the first thing says, number 10, write out the complete electron configuration for sulfur. Okay, so first thing, you got to figure out how many electrons, and we're going to need to take a look at our periodic table. So I'll pause it and pull up that periodic table. I realize that I'm going to need a periodic table here. So go ahead and added one to the end. So first of all, sulfur. So I'm going to have to slide over to the end here. So here's my periodic table. And we're going to take a look at sulfur. So this is going to be kind of challenging, I think, but I think I'm going to do some stuff here and then we'll kind of go back. So first of all, I got to figure out where the heck sulfur's at. And so here's sulfur right here, number 16. So that's what we're going to be doing. We're going to be going to number 16, which means 16 electrons. Okay, so all of these are going to start the same way, meaning that you're always going to go from hydrogen. And so one of the things on your periodic table I would probably do is add a 1, a 2, a 3, a 4, a 5, a 6, and a 7. Those are your energy levels. I would go over to scandium, which is right here, and I would write in that corner right there, I would write 3D because the D is off by 1. So I would go ahead and identify that. And then, of course, yttrium would be 4D, etc. F block, which you are not going to really use in IB, I would come down to the F block and I would write in a 4F and 5F. So this is kind of the way we're going to approach it. So I'm going to do the configuration in this space here, I guess, because I don't have a ton of space. So let's go and fix that real quick. So we're going to put our 3D right there. Maybe these different colors. See if the red shows up better. 3D. Okay. So sulfur. So we're always going to start at the beginning. So always going to start at the beginning, and we're going to always ask ourselves, what row am I in, and what block am I in? So I'm at hydrogen, number 1. So I'm at 1. This is the S block, and then hydrogen and helium. There's 2 electrons, so 1s2. Okay, so what I mean about blocks is that this area here, that's the S block. So that entire thing is the S block. So all of this is the S block and helium. So there's actually 2 areas to the S block. Okay, so after I did helium, I would go ahead and I'd come down here and we'd be hanging out at lithium. So what row am I in? Well, I'm in row 2. What block am I in? Well, I'm still in the S block. And then how many can I have? Well, lithium is 1, beryllium is 2. So that takes you 1s2, 2s2. So if you stop right now, you'd have beryllium. So we're going to go over to boron. So right here, we're boron. So boron is going to still be in row 2. But this is no longer the S block. This right here, this is your P block. So we're going to need a different letter. So let's go ahead and go back. And we're going to go row 2 still. P block. And how many can hold? 6. 1, 2, 3, 4, 5, 6. That takes us to neon. Okay. After neon, we're going to go down here to sodium. So we're at number 11 right here. So we're in row 3. Back to the S block. And we're going to go 11 and 12. So that's 3s2. And then you slide over here and see there's where we're going. That's where we want to go, sulfur. So we're getting really close. So we're still in row 3. We're still in row 3. But this is the P block over here. But I'm not going to do 1, 2, 3, 4, 5, 6, because if I did that, I would end up at argon. I'm going to go 1, 2, 3, and 4. And I'm going to stop right there at sulfur. So 1s2, 2s2, 2p6, 3s2, 3p4. So there's your sulfur one. Write that down. I think I'm going to pause it here. Check this video. I had a lot of pauses and stops, so we'll see how it looks. But we'll pick up the other example in the next video. And you can go